Good day, viewers. You're welcome to my YouTube channel. This is Kemizi and I'm Echo Jeremiah. Please, if you've not subscribed to my YouTube channel, do that by clicking the subscribe button now. Today, I'll be explaining the preparation of lime water. So, when you hear the word lime water, it is a saturated aqueous solution of calcium hydroxide. A saturated aqueous solution of calcium hydroxide is lime water. Alright, when you hear the word saturated solution, is a solution in which no more solute can dissolve at that particular temperature. So when you want to prepare this, you should expect to see some insoluble solute. And take note of this: calcium hydroxide is sparingly soluble in water. So calcium hydroxide is used to identify the presence of carbon dioxide gas. And carbon dioxide gas in the laboratory can be gotten from two sources. Number one is action of heat on thiazocarbonate 4 salt or hydrogen thiazocarbonate 4 salt. Alright, so when you eat salt containing carbonate, it gives you carbon dioxide gas. For example, this is zinc 2 carbonate, thiazocarbonate 4. Once you eat this salt, it will decompose to give you zinc 2 oxide and carbon dioxide gas. So this carbon dioxide gas can be identified using calcium hydroxide, which is your lime water. Or when you decompose sodium bicarbonate, it will give you sodium carbonate plus water and carbon dioxide gas. Alright, so this carbon dioxide gas can further be detected using calcium hydroxide, which is lime water. And take note of this: not all carbonate salt can be decomposed. Okay, carbonate salt of sodium, which is sodium carbonate, and potassium carbonate are stable to heat. So these two salts cannot be decomposed by heat. Alright, but aside these two salts, any other carbonate salt can be further decomposed by heat. Alright, so this is one way we can get carbon dioxide gas. And the other way you can get carbon dioxide gas is the action of dilute acid such as HCl or sulfuric acid on carbonate, okay, on thiazocarbonate or hydrogen thiazocarbonate 4. Alright, and this is one chemical properties of an acid. We know that when an acid reacts with a salt, with a carbonate, let's say sodium carbonate, alright, it will give you the salt of the acid, sodium chloride, plus water plus carbon dioxide gas. Alright, you can go further to balance this equation. Alright, so this carbon dioxide gas produced can then be determined using calcium hydroxide. So now what happens when this carbon dioxide gas is passed through lime water? Alright, this is lime water, calcium hydroxide. When carbon dioxide is passed through lime water, it will give a milky color. Alright, it will form calcium carbonate plus water. This calcium carbonate is a white precipitate, alright, which gives that milky coloration. So that is how you test for carbon dioxide. And if you further pass more carbon dioxide through the solution, alright, that means this solution, from this milky solution, you pass more carbon dioxide gas through it, the white precipitate will disappear to form calcium hydrogen thiazocarbonate 4, which is soluble in water, hence that white milky color will go off. So now let's go back to the preparation of lime water. So we'll start first by weighing out 25 grams of calcium hydroxide. And here we go. So this 25 grams of calcium hydroxide. And then I'm using a magnetic stirrer here. If you don't have this, you can use a stir rod. Alright, so you don't want to spin it too fast so that you don't spill the water out. You add the 25 grams of calcium hydroxide to about 800 cm cube of water, and you stir properly to ensure that the solute is dispersed homogeneously in the liquid. And you observe that calcium hydroxide is sparingly soluble in water. You stir continuously for some minutes, and then you dilute to 1000 cm cube with distilled water while still stirring for some minutes. When you're done with that, you allow the solution to stand for 24 hours. This is to ensure that the calcium hydroxide dissolves properly and the solute will settle down to the bottom of the beaker, and then you decant the top, the clear solution of it, which is your lime water. If need be, you can filter with a filter paper to get the clear solution. So here's your filter paper. You fold into 2 and into 4, and 1/4 of it you fold it into 2. You fit it very well into your funnel, and then you carefully pour out the top of it via the filter paper to get the clear solution, which is your lime water. So you carefully decant the top of it, which is your lime water, through the filter paper. And here we go. So here's some part of it. You can see how clear it is. So I'll go further to test the lime water. So in this first boiling tube here, I have zinc 2-triazocarbonate 4 in it, so we'll be heating it to give out carbon dioxide gas. And in this other boiling tube here, I'll be adding my lime water into it, which is what I have here. So you pour your lime water into it carefully. You find out that it is clear and colorless, and then you allow the carbon dioxide gas to pass through the lime water. You can set up your apparatus this way. So you observe that when we heat the zinc 2-triazocarbonate 4, which I'm doing now, it will give out carbon dioxide gas, and when this carbon dioxide gas passes through the lime water, it turns it milky, which is the calcium triazocarbonate 4 white precipitate you see. So you can observe the gas going into the lime water now. And gradually you observe that the lime water is turning milky, as you can see clearly from this demonstration.